Okay, so let's observe what's going on. So we say new node next, which is right here. Go ahead and point yourself to what node is currently pointing to. So basically node is pointing here. We make a copy of this pointer right here, right? So we make a pointer, and basically we say, okay, go ahead and point right here. We just making whatever node next is doing, new node next is going to be doing. So we create this link. But then we say that, of course, the node next, now instead of pointing here, should be pointing to the brand new one. So we just say, all right, new node is the pointer to this B node, and simply put, node next should be now pointing, we already have a pointer to it in terms of new node. New node points here, right? So node is the pointer that points to here, right? And so what happens is that we just say new node should be the place to where this node is pointing to. So now we have this brand new link and this brand new link. And because we're executing this statement, we're effectively getting rid of the original link that existed right here. So there's no more link over here. Instead, we have the structure as a result of those two simple statements. So new node next points to whatever the node next is pointing to, which is node C, and then the node is now pointing to brand new node, and we have this result. Okay, so again, I apologize for the fact that although there's this simplicity of idea, but the code becomes somewhat convoluted, and there's lots of things to watch out for. There is this presence of the structure, and inside that structure, to access internals of that structure, we use this pointer to member dereference operator. This thing right here, the little arrow. And every time we access next, we're basically going through the pointer to an object. So insert front is a function that takes two parameters, node and new node, and those are pointers to the node. And because we're trying to maintain C style, C actually, anytime you have a pointer to a structure, C syntax requires struct to be placed in front of the name of the structure. In C++, you don't have to do it, but C++ still supports the syntax and doesn't complain. So that's why we kind of use C style function parameters here, which using pointers to those two things. Let's take a look at the main function as well. In the main function, again using the C style declaration of nodes A, B, and C, what I do here, I just say struct node. Now in C++ you don't have to say struct, but you can, right? Because it's like backward compatibility with C. And so node A, B, and C, remember, those things are extremely primitive. The structure node is extremely primitive. It has no member functions. It just have two pieces of data. One piece of data is the value, and another piece of data is a pointer to potentially another node. So when I create them like this, they're completely unlinked. They don't know about each other's existence, and each pointer here inside A, B, and C is some sort of garbage, right? It's just not well organized at all. So what I do here, then I say, all right, first of all, let's store some data, 12, 99, and 37 in nodes A, B, and C. So the data here gets populated with 12, 99, and 37, right? So I am making some steps to get organized, right? So first I create objects, then I populate some data inside those objects. Then I say, let's build this linked list using this insert front example. For that, insert front saying, hey, A, so apparently this is A contains 12. So I'm telling A, why don't you point to C? So first, I insert C in front of A, right? So A, which contains 12, begins to point to C, because that's what the insert front will do. In the next line, I say, A, insert B in front of you. And that's exactly what's going to happen. So eventually, we're going to have a linked list. A pointing to B, B pointing to C, because that's what insert front does. In case if there was another A is pointing to C, then B will be nicely inserted right in the middle. Right? And so finally, to make things in good order, C next has to point to null. And we say, why don't you point to null, so that we have a nice ending. Interestingly, using this very simple function that contains only 2 lines of code but looks somewhat convoluted with everything that it does, with this observation, observe the following. I chose this node to be the header, the head node of everything else, and I built the entire list only by using A. I said A insert C, A insert B. I could have created more of these, right? And I still could manipulate only this node to say, okay, why don't you go ahead and insert something in front of yourself, right? And so I really chose this A node to be the header of my list. Or also programmers often use name root of the list, basically the beginning, right? So this is interesting. With this simple structure and this very simple function, really, which we can observe step by step what it does, right? And what it gains access to, and it's a free function, right? We can indeed go ahead and build this list. So this is an example of a C-style linked list, right? So we have some functions. Similarly, we could add remove, right? We could add remove, like take out the node, and we could maybe demonstrate this later on. But this demonstrates the concept. We were able to construct individual nodes, and we were able to populate them with data, and we were able to construct some sort of a list that does something to construct it. Okay. So C++ node class could then be organized very nicely. For example, instead of just saying, look, there is in prior example, we had the struct, but we could say, listen, this insert front really works only with nodes. So maybe this should become a class, and this should become a member function. So here's the demonstration right here, class node. So since we're turning the page to another approach, let's save this recording, save this.